So good afternoon everyone. So we will start at 3:05 p.m. So we will just wait for a couple of minutes for others to join in. So as I already mentioned in the chat box, new participants would be only allowed after the particular problem is solved. So in between, no person will be admitted. I hope I'm clear. And also, if you have any doubts regarding a particular problem, a few minutes will be given to type in your doubts regarding that problem. You have to use this chat box of Google Meet. I'll be just checking it after every problem. Only chat box should be used. So it's 3 p.m. and no one is joining. I think we can start. So good afternoon everyone. I'll be just giving the introduction first. My name is Musa Rafiq. I'm a PhD student in the Department of Electrical Engineering at IIT Kanpur. I'm your course TA, and this session will be regarding the tutorials that we had in week 3. Uh, I hope you have gone through the lectures of week 3. Problems related to week 3 will be discussed. That will help you in your assignments and quizzes. So Professor Shantanu Chattopadhyay is your course instructor and I'm your TA. So I think some people have joined. Let me just admit them, then we can start with the problem. So let me just start with this first problem. The first problem that is given here is question number 1. Given the Boolean function f of a, b, c, d, a 4-variable Boolean function, is the sum of these min terms 4, 6, 7, 10, 11, 12, 14 and 15. And we have to minimize it and find out the equivalent expression for this. So we will be using mostly the Corno map approaches, the K-map approaches to solve these kind of questions. So we have this 4-variable here, a, b, c, d. So for a 4-variable, we have this Corno map like this, where this MSB is here and LSB is here, and we have this written as like this: 0, 1, then 3, 2, 4, 5, 7, 6, then 8, 9, 11, 10, and then 12, 13, 14, 14. This is a 4 plus 4 4-variable K map. And in the function, the minterms that are equal to 1 are 4, 6, 4, 6, 7, 10, 11, 12, 14, and 15. So we'll be just marking them 1 like this: 4, 6, 7, 12, 14, 15, 11, and 10. So this is a 4-variable K-map. So we will just first try to find if we can make an octet. As you can see, octet is not here possible. So then we can just look for this chord. If we can make any chords, I think we can make chords. So let me just show you the chords that are possible here. First, this chord is possible, covering these minterms 7, 6, 15, 14. Then this chord is possible. I have used this different color schemes to show you the different chords so that you won't mix them up. So this chord covers these minterms 15, 14, 11, 10, and then finally we have the another chord like this 4, 12, 6 and 14, which covers, sorry, we have this chord which is in green color, which covers the minterms 4, 12, 6, 14. So we have here 3 chords. So this chord which is marked in, I think, red color will be giving us the minterm as, so a is not changing, we can write as a. This chord, red color chord, is giving us this term a, and in this c is not changing, so it will be ac. Then we can look at this chord, yellow color. So in this again a is not sorry, this was B, this was not A, this was B, sorry, my bad, this was B. Then we have this chord, yellow color chord. In this, A is not changing, so we will write as A, and in these terms, C is not changing. And then we have this green color chord, which is this and this. In this, D dash is not changing, and B is not changing. So our final expression will be sum of these three terms. So this is our final expression, AC, this is AC, plus BC, and plus BD dash. So our answer would be AC or BC or BD dash. This is option A. So option A will be our correct answer. So if you have any doubts regarding this question, you can type it in the chat box. I'll be giving a couple of minutes so that you can type in your doubts. So I think there are not any doubts regarding this question. I think we can proceed with the second question, that is problem 2. So now we have problem 2. So what this problem says is minimum sum of product expression for f of w x y z shown in Corno map below is. So here we have in this Corno map where some of the min terms are 1 and don't care conditions are also given here. So we are asked to find the minimum expression in SOP form. So we'll be again using a 4 variable K map to find the answer. So let me just show you again this 4 variable K map that is given. This is a 4 variable K map where y is our MSB and x is our LSB. So we'll construct it like this: 0, 1, 2, 3. Basically, this is 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. And these correspond to the min terms as 0, 1, 3, 2, 4, 5, 7, 6, then 8, 9, 11, 10, and 12, 13, 15, 14. And these are the ones, these min terms are 1, and these are the don't care conditions. Now we have been asked to minimize the following expression using the K-map. So we'll just first look at for the octet, if we can find the octet in this case. Just like the previous case, here no, just wait. No octet is no octet is possible here. Then we'll just look for the chord. So I think we can construct a chord. So we have this chord. Just write chord. We have this chord using this don't care condition. We have this chord which is shown in this green dashes. This one. So this will give us the term y is not changing y, and x dash is not changing x dash. This chord will be giving us the term y x dash. This one. Then we can have this another chord that will be covering these terms, which is shown in red dash like this. So this chord will be giving us the terms z dash coming from this and w. So all ones are covered, all ones are covered. So our final expression would be x dash y or z dash w. X dash z will be messed up somewhere. Let me just check the question. Why is it there's a dash? So this is. Let me just check it again. We have done something wrong with this term. This is one chord. Y dash. Sorry, this was z. This was z. Zx dash. Because y is changing and z is remaining constant. This is zx dash. Zx dash. And then this in this term z dash was constant, and x is constant. Sorry, w was not constant, x was constant. So this was x dash z. So the answer will be zx dash plus z dash x. I'll show it again. I have messed up a little bit. I'll just show it again. So the question had given us this K-map and asked us to find the minimized expression. Some students are there. Let me just admit them first. So someone has mentioned the question is not clear. So I'll be just showing you this figure. So don't worry about that. The question has given us this K-map with some don't care conditions, and we have to find the minimized expression. So this is our 4 variable K-map. So we have to find the minimized expression. So this is our K-map, 4 variable K-map. In this, these are the ones and these are the don't cares. So we have to find the minimized expression. So octet was not possible, so we just went for the chord, and using the don't cares we constructed this chord highlighted by these green dashes. So with this chord we have the term, since y is changing, so we have this term z and x dash. So it is x dash z with respect to this chord, and then we have this another chord shown by the red dashes, which is this, in which z dash is constant and x is constant. So the term coming out from this chord will be xz dash. So the final answer will be x dash z plus xz dash. So that will be our answer, x dash z plus xz dash. So this is option B. So this will be our correct answer. Any doubts regarding this question? Please type in it in the chat box. Yeah, you can say that, but X conditions are given, so we don't have to go there. That is a different case. XOR is AB dash plus A dash B. That's true, but don't care are also there. So that is for two variable XOR condition. AB dash plus A dash B. I hope I'm clear, Shankar. So we can move to the next question. That is question number 3. So the question 3 is a very simple question. The question 3 asks us to write the Boolean equation for each line in the truth table where output is 1. This is a simple equation. So it's basically canonical POS form. So here we have these 3 variables A, B and C, and this is the output Q. So first we will just write the minterms for which the output is equal to 1. So we have this, this. So for four conditions, the output is 1. Here A is 0, B is 1, and C is 0. So it will be A dash B C, B A dash B dash C dash. Then we have this condition where A is 1, that will be A, and we have B dash and C dash. Then we have this third condition where A is 0, B is 0, and C is 1. So it will be A dash, B dash, and C. Then we have this final condition where all variables A, B, and C is 1. So it will be A, B, C. So the final expression will be sum of the above terms, that is Q is equal to A dash B C dash plus A B dash C dash plus A dash B dash C plus A B C. So I think this is option, this is option A. So option A will be a correct answer. Any doubts regarding this question? This was a pretty simple question, but still I have to ask. Any doubt regarding this question? No, question is simply just asking us to write down the equation. It was just as kept it there. So no minimization. So just to write the equation, that's all. Ashanka, I hope I am clear again. So we have done 3 questions, 1, 2, and 3. So now we can move to the question 4. So the question 4 asks us to find the sum of product expression. Okay, so we are given the sum of product expression, so we have to find the point of we have given this sum of product expression. So sorry, we are given this product of some expression. Now we have to find the sum of products. So f is equal to x and y or z, then and again x or y or z. So what we will do, we will just multiply these two first. So it will just reduce to xy with xz. So we have this square bracket, and the whole term will end with x plus y plus z. So this is what I have written here. Now we will just multiply these two terms, and so this will be xyx. So xyx is simply xy because a dot a and a is a. So I'm using that property. So xyx is simply xy. Then xyy is equal to xy again. Then xyz. Now these two terms. So xz x. So it will be xx again. So xx is equal to x. So it will be only xx. Then this is xzy. So it will be again xyz. And then finally we have xzz. So it is xz. So that's what I have written here. So I am missing one xyz term. So here it will be one xyz term. Since these two are similar, so we know that a or a is simply a. So using that property, so this is xy plus this is xz and this is xyz. So the final expression will be xy plus xz plus xyz. So this is our final expression. So option C is our correct answer. Any doubts regarding this problem? Please type in. I'll just wait for a couple of minutes. we are done with this question 4c. Now we can move towards question 5. So question number 5. Question number 5 asks us to minimize the following Boolean function f of a, b, c, d. So f of a, b, c, d means we have four variables, namely a, b, c, and d, and it's the sum of min terms 0, 1, 3, 5, 7, 8, 9, 11, 13, 15. So we have been given this function and we have to minimize it. So we will again use a four variable k-map. So let me just show you first the four variable k-map construction again. So this is a four variable k-map. So this is 0, 0 corresponding to a dash b dash. This is 0, 1 corresponding to a dash b. This is 1, 1. This is 1, 0. And then this is 0, 0, 0, 1, 1, 1, 1, 0. And corresponding to these min terms are like this 0, 1, 3, 2, 4, 5, 7, 6, 8, 9, 11, 10, and 12, 13, 14, 15. So 0, 1, 3, 5, 7, 8, 9, 11, 13, 15 are equal to 1. So I have just marked them as 1, as you can see here. Min term 0 is 1, 1 is 1, 3 is 1, 5 is 1, 7 is 1, 13 is 1, 15 is 1, and so on 8, 9, 11. So in the four variable k-map, we will just first look for the octet. Sorry, octet. So is there any octet? Yes, there is one octet which I marked by this red color. So this is an octet. So corresponding to this octet, we will be having only one variable, and that one variable is, so these are all changing, a and b are changing, so none of the contribution from them, and c is also changing from c dash to c, so only d will be taken up. So from this octet we have this contribution d, and then we can have another. Then we need to, so is there any other octet? No, we can't construct any other octet. Then we have to look for the chord. If we can include the remaining min terms with the chord. So I think yes, we can include the min terms 0 and 8 with the chord. So we'll have this chord marked by this dashed green square. So this is our chord, and this chord will give us a term. A is changing. This will give us a term b dash, c dash. So our final minimized expression after solving this four variable k-map according to the given conditions will be f is equal to d plus b dash c dash. So f is equal to d plus b dash c dash. So if there are any doubts regarding this question, please type in. So I just forgot to mark the answer first. Yes, we just mark the answer. So the question was f equal to d plus b dash c dash. F equal to d plus b dash c dash. So option B is the correct answer. So question 5 has correct answer, that is option B. So any doubts and comments, please type in the chat box. So I can see we are not having any doubts. So I think we can move forward to the next question, that is question number 6. So the question number 6 is again a minimization problem. So here we are given this four variable function a b f of a b c d. Sorry, we have this minterms that are equal to 1 are 1, 3, 4, 6, 8, 9, 11, 13, 15, and we are also given some don't care conditions which are 0 to 14. Don't care conditions are marked by this x in the K map. So we will be again using a four variable K map. So this is a four variable K map where we have this 0 0 0 1 1 1 1 0 and then 0 0 0 1 1 1 1 0, and corresponding to this we have these minterms 0 1 2 3 4 5 6 7, then 8 9 10 11 and 12 13 14 15 is in this row. The reason I am repeating this again and again because I have seen in my experience also people in hurry mess this thing up. So that's why I'm making this template. I'm making showing this template again and again so that you won't make any mistakes in your examinations or while you're solving the problems. So here we are giving this 1 3 4 6 8 9 11 13 and 15 equal to 1, and we are the don't cares 0 2 and 14. So I have marked them in this plot, sorry, in this map like this. So now we have to minimize this thing using this rules of the key maps. So first we'll just look for the octet if there is any octet. So let me just check. I think we can't construct any octet from these conditions. Now just look for a chord. So we'll be looking for a chord. So this is the one chord we can construct marked by this dashed square. So this is a chord, and the contribution from this chord is A and D is there, AD. Then we have this another chord marked by this yellow dash line, dash square. So it will be contribution from this chord will be B dash D. So are there any remaining minterms? Yes, there are three remaining minterms. So let me just check if we can construct the cover them using the chord. Yes, we can. So we have this chord marked by this blue dashed square covering this minterm 8. So from this the contribution will be B dash C dash, and now we have this remaining minterm. So let me just first check it can be covered by a chord. So using road cares we can cover it by a chord marked by this gray dashed square. So the contribution from this will be A dash D dash. So our final expression will be sum of these terms. So the final expression will be AD is here, B dash D is here, B dash C dash is here, and A dash D dash. So let's just check which option was this. F equal to AD, B dash D, B dash C dash, A dash D dash. So option A. So question number 6 is having the correct answer in option A. I hope I was clear with this question. If there are any doubts regarding this question, please type in. So question 6 had the correct answer as option A. can see there are not any questions regarding this question problem. So we can just move towards problem 7. So problem 7 asks us to find the output of the logic circuit. So the question says that the output of the logic circuit given below represents which gate. So we have been given this logic circuit and we have to find out the output in terms of which gate functionality it does. So let's just start. We first take this, we will just take them individually. We will just first take this NOR gate. So we have input A given to it to this NOR gate. So this is A plus A or A whole complement. So using De Morgan's law, it's A complement and A complement. So we know that A dot A is equal to A. So this thing here A is A bar, A complement, so this will be A bar. So what this NOR gate simply does, this NOR gate is used as a NOT gate here. So given an input A, we have this output as A bar, and for this we have this is again same, but I'll show it elaboratively. I'll elaborate on this. So this is again B plus B complement using De Morgan's law again. So it is B complement and B complement, and this thing is simply B complement. So here we will have B complement. Now taking this gate NOR gate 3, marked as NOR gate 3 here. So we have the inputs as A complement. I may sometimes refer to this A complement as A dash and B dash, A dash or A bar, or simply A complement. So mind these notations or these how I call them. And the another input is B dash. So these two inputs are for this NOR gate. So the output will be A dash or B dash whole complement. So this will be A dash or B dash whole complement will be simply A bar bar dot B bar bar. So this is simply AB, and now this AB is fed to this NOR gate 4. If I can number them as 4, and this was 1 and this was 2. So this AB is fed to this NOR gate 4. So what it does essentially does is simply a NOT gate, just like this. But I will elaborate it. So AB is fed to NOR gate like this. So we can write it as AB or AB whole complement. So we can use the De Morgan's law. It will be simply AB bar. So AB bar is which gate? It's NAND gate. So the whole logic circuit represents the NAND gate. So option D is the correct option for question number 7. So I can see some of you are typed in the correct answers. So are there any doubts regarding question number 7? Shortcuts are simply, I just elaborated it, but you could have remembered it. You know that NOR and NAND are universal gates, and these gates can be simply constructed from them. And also, with experience, you can just simply tell them which gate does which functionality. This is simply NOT gate, and this is NOT gate. So output was A bar, B bar, and then it was a NOT gate again. No, sorry, not gate, NOR gate. So it was A bar plus B bar, the whole bar. So you knew, once you knew AB was here, so this was not, so it was AB bar. So this was simply NAND. So when once you get the hold of the subject, you can just easily visualize them, which gate does which functionality. So shortcuts are that. With experience, you'll be able to do it within a couple of seconds. So Shankar, I hope you got my point. But if you are new to this course as a beginner, I suggest you write outputs at every after every logic gates output. So individually write output at every point. Like what I'm going to say is write output here, write output here, then do the functionality here, write output here. In that way, you can't you'll make very less mistakes. As circuits get complex and complex in future, that time you can make very less mistakes. And with experience, then you can just give the correct answer just by looking at them. So am I clear or any other doubts regarding this question? So you guys know this NAND and NOR gates are universal gates. You can construct any of the gates from these two gates. Now moving forward to this question number 8. Question number 8 states that which of the following gives the simplified sum of products SOP expression for the Boolean function f equal to m0 plus m2 plus m3 plus m5. So someone has requested to join in. Let me just. So the question asks us, the question asks us to find the simplified sum of product expression for the sum of these minterms m0 plus m2 plus m3 plus m5, where m0, m2, m3, and m5 are minterms corresponding to inputs a, b, c, and a is the MSB and c is the LSB. So this is a three variable expression, and the three variables are namely a, b, and c, and a is our MSB. That's why it is represented here in this three variable K map, and c is our LSB. So this is a representation of a three variable K map, and the minterms that are equal to 1 are 0, 2, 3, and 5. So I have marked them accordingly. So in the three variable K map, let's just first check whether we can construct any chord. So if you just look at the K map, we can't make any chord out of these. So next we have pairs. So let's just look at if we can construct any pair. So we can construct this pair. So this pair gives the expression a dash from this and b, a dash b. Is there any other pair we can construct? Yes. So marked by this red dash pair, we can rectangle, sorry. So we can construct this pair. So this gives the contribution as a dash, c dash, and then we have this remaining minterm m5. Can it be covered by any other pair? No. So this will be a whole term. It will be a, b dash, c. So the final simplified answer would be sum of these three terms: a dash c dash plus a dash b plus a b dash c, a dash b, a dash c dash, and a b dash c. So this is our option B: a dash c dash, a dash b, a b dash c. So option B is our correct answer. Any other doubts regarding this part? So question 8 is done, having correct answer as option B. So now we can move towards this question 9. So the question 9 asks us to find the Z. So we have to find the output of this logic circuit. I'm just again showing the elaboratively this part. So these gates are marked as 1, 2, 3. So these outputs are simply for notation x1, x2, x3. So taking gate 1, which has inputs A and B, this is a NAND gate. So x1 will simply be equal to A, B, bar. Then we have, so this is A, B. Then we have this gate number 2 with inputs as C, D, and we have this NAND gate. So x2 will be equal to C, D, bar. And then we have this third gate with input as E and F. So x3 will be equal to E, F, bar. So now Z will be simply equal to, it is a 3 input NAND gate with 3 inputs as x1, x2 and x3, and this is Z. So Z will be simply equal to x1, x2 and x2 and x3 whole complement. So if we can use the De Morgan's law here, so it will be, using De Morgan's law, it will be x1 bar plus x2 bar plus x3 bar, and plugging in these values of x1, x2 and x3 here, we get AB bar whole bar plus CD bar whole bar, then EF complement whole complement, and we know this A complement is simply A. So this is here equal to AB complement whole complement is AB, CD complement whole complement is CD, and EF complement whole complement is EF. So our final expression would be Z equal to AB plus CD plus EF. So this is option B. So question 9 had option, correct option as option B. So are there any queries or doubts regarding this question? So let me just move to the last question of the day of this session, which is find the number of essential, find the number of essential, mind this word essential, find the number of essential prime implicants for the given map, K map. The essential prime implicants are simply prime implicants which cover a min-term that is not covered by any other prime implicant. So we have this K map equal to summation of 0, 1, 2, 8, 10 and 12. So we are asked to find the number of essential prime implicants. So let's first just look for the octet. So there are we cannot make any octet here. So let's just look for the chord. So we can construct a chord for this like this, corner points covering min terms 0 to 8, 10. So can we construct any other chord? the map, we can't construct any other chord. So just look for the pairs. So to cover this 12 and 1 and 6, we can have pairs like this. First this one, and we can have another pair like this one, and to cover 6 we can have another pair like this one. So here the essential number of essential prime implicants is simply 4. This is 1, this is 2, this is number 3, and this is number 4. So the number of essential prime implicants for this K map, given K map, is 4. So are there any doubts regarding this question? Yeah, please type in. Prime, it means simply prime implicant through which we can cover a midterm. Like we have this square, octet, chord, pair. Prime implicants are simply they can be through which we can cover any other midterm. So let's say if there was a one here, let's say one, let's say here. Let me just show it in another game. Yeah, yeah. So this here we can have any other prime implicants like this. In this portion, let's just forget this. Let's just forget this is not here. So we can have this chord. So this 9, 11, 13, 15 is covered by this chord. And we have this another chord 1, 3, 9, 11. So this chord covers 9, 11, 1, 3. And this another chord covers 9, 11, 13, 15. So this 9, 11 is covered by two chords. So it, among them, both of them are prime implicants. But essential prime implicant will be the one which is not which covers a minterm. Let's say here I have a minterm. This is covered by this pair, and these minterms are not covered by any other octet, any other pair. So by essential prime implicant will always be present in our final solution. There can be multiple prime implicants, but essential prime implicants, whenever we minimize using K-map, this essential prime implicant term will always be present in our final solution. So that's what essentially means this prime implicant and essential prime implicant. So how to identify prime implicant is simply just find the octets, chords, pairs in a K-map. Some of the minterms will be covered by two chords. So they are both of them are prime implicants, but only essential prime implicant will be only that one which covers a minterm which is not covered by any other minterm. You see in the last question I showed this minterm 1. So this minterm 1 was not covered by any other chord or any other pair apart from this pair. So this pair has to be there. So this pair will always be in the final solution. So is this pair and this pair and this chord. So that was it. I hope I am clear. So this session was regarding this week 3 lectures. I hope this will help you with your assignments and some further problems. If there are any other doubts, please type in the chat box. So when you are looking for this four variable K-map, you have to first look for the octet. So if this is covered by an octet, so that will be your first prime implicant. Then you have to move forward to this chords, then pairs. So we have to follow a sequence. If an octet is formed, form octet. If not, an octet is if octet is not formed, then move towards to this chords, then pairs. It is in the powers of four. Sorry, two, 8, 4, 2, 1, like that. No, not necessarily one chord. It can be one octet also and one pair also. So if you have any further, you need any further clarification, I suggest you go through this book, Digital Circuits by Morris Manu. It's uh, it's it's explained there with an illustration of both prime implicants and essential prime implicants. Yeah, one chord will give one prime implicant. No two. It can't be two. So are there in? Do refer this book, Morris Manu. It's a really good reference for this course. Are there any other questions and doubts? I'm not aware of that. I have during my BTech days I have referred this Morris Manu, so that's why I'm suggesting it. If there is any other book that is, I'm not aware of that. So if you are able to understand it from that, do refer that. So this was all for this today's session, week 3 session, live session. So next week we will have a live session pertaining to week 4 lectures. It will be on the same time and same day. That is Sunday, 3 p.m. to 4 p.m. So next Sunday will be I think 21st August. So we'll meet next Sunday hopefully. That was all for today. Thank you guys.